Example 4 says, given that cosine of theta is equal to 3/5 and sine of theta is less than 0, use identities to find the following trig expressions. So I'm going to go ahead and I'm going to draw my xy plane, and we know that cosine is positive since it's 3/5, and cosine is positive in quadrants 1 and quadrants 4. However, we know that sine of theta is negative, and so out of quadrants 1 and quadrants 4, sine is negative in quadrant 4. So I'm going to draw my right triangle. It's going to look something like that. We can call this theta here. And I know that the cosine is adjacent over hypotenuse, so then this length, and this is 5. I'm just going to call that length A, and we want to figure out what that is with the Pythagorean theorem. So we have 3 squared plus A squared is equal to 5 squared. We get A squared is equal to 25 minus 9. And then we find that A is equal to 4. However, A represents the y coordinate of this point here, and so we know the x coordinate's 3, and because it's below the x-axis, we know that the y coordinate is negative 4. So although we found A is 4 here, we really want this value to be negative 4. Again, although distances are not negative, we want to think about the y coordinate. Now that we have all of this information, this is going to help us find each of these 3 things. So let's start off with sine of 2 theta. We know from the identity up above that sine of 2 theta is equal to 2 sine of theta times cosine of theta, which is equal to 2 times sine of theta is opposite over hypotenuse, so that's going to be negative 4 over 5 times cosine of theta, which is given to us in the problem. We know that cosine of theta is equal to 3/5. And now we can go ahead and do some multiplication, and our numerator is going to be negative 24, and our denominator is going to be 25. So that is sine of 2 theta. Now, cosine of 2 theta, there are 3 variations of the identity that we can use. I'm going to use the one that says 2 cosine squared theta minus 1. They should all give you the same answer though. So 2 times cosine squared theta is going to be 3/5 squared minus 1, like that. And if we square 3/5, that gives us 9 over 25. Let's see, that's going to equal 18 over 25 minus 25 over 25. So I changed the 1 into 25 over 25, and that will give me negative 7 over 25. My suggestion for you is I would use one of the other 2 identities other than the one that I ended up using, just so that you can verify that the other 2 identities will work out as well. So any of the 3 identities should give you a final answer of negative 7 over 25. Now the last one we want to do is we want to figure out tangent of 2 theta, and that is equal to 2 times tangent of theta over 1 minus tangent squared theta. And I'm just pulling that from the list of identities that we had above. And tangent of theta is equal to opposite over adjacent. So that's going to be the opposite value is negative 4, and then the adjacent is 3. Lots of algebra today, so let's simplify this. So that's going to give us negative 8 over 3 over 1 minus 16 over 9. And that is going to equal negative 8 over 3 over 9 over 9 minus 16 over 9. That's going to be negative 8 over 3 over negative 7 over 9. And then we want to multiply by the reciprocal, so that gives us negative 8/3 times negative 9 over 7. And if we multiply that, let's see, I can do some reducing. So 9 over 3 is 3. And then if we multiply now, it should give us negative 24 over 7. So that is the value of tangent of 2 theta. Example 5 wants us to prove that cotangent of x times sine of 2x is equal to 1 plus cosine of 2x. And this one, you could probably start with either side. So I'm going to start off with the right-hand side, but maybe see if you can play around with it. Maybe you want to start off with the left-hand side. You should still be able to get the same answer. So I have 1 plus cosine of 2x, and I can rewrite this thing now as 1 plus, I'm going to use the double angle identity, and I'm going to replace this with, I'm going to choose the one that says 2 times cosine squared x minus 1. And I can also drop the parentheses. And this one here and this minus 1 here will cancel out. I just want to note that I got this by using the double angle identity. And then we'll get 2 cosine squared x. From here, I can rewrite this as 2 times cosine of x times cosine of x. And that's just using algebra. And now I'm going to do something kind of slick here, so stay with me. I am going to divide this term by sine of x, and I'm going to multiply this term by sine of x. And really, that's just multiplying by 1, since we're basically multiplying by sine of x and dividing by sine of x. So we're just multiplying by a fancy 1. And then I'm going to rewrite the order of this to be cosine of x over sine of x times 2 sine of x times cosine of x. So the justification for that step was reordering the multiplication, and multiplying by fancy 1. Okay, well, why did I do that? I'm going to come up here, and now I can use the reciprocal identity, because cosine over sine we know is cotangent of x, and then 2 times sine times cosine of x we know is sine of 2x. So this we got with the reciprocal identity, and then this we got with the double angle identity that we have above. And that is equal to the right-hand side, and so we are done with this example.